Texan Global School. In this video, we will discuss the proposed study strategy of our algebra workshop after completing the arithmetic, set theory, and geometry courses. First, it is crucial to familiarize yourself with different mathematical symbols. The videos, archives, and PDFs of the workshop provide several tools to analyze them. A dictionary of symbols is recommended to be constructed while studying the topics. If the student is unaware of the mathematical symbology, it will create delays through the classes and exercises. The second class implies studying how to transform common language into algebraic language. Any letter can represent any number, for example. Or two letters or variables multiplied is the product of two numbers. The algebraic notation and terminology describe grounded elements for algebra. The letter x, for example, can represent any given value such as 4 or even the rational number, pi. An algebraic term can be a specific number, a general number, or a combination of them as products, quotients, powers, or roots. Terms are separated by additions or subtractions. Each term has a sign, numerical coefficient, variable, and/or exponent. Understanding the characteristics of algebraic expressions and the difference between polynomials and non-polynomials is also essential. Another topic of importance is to understand that the absolute degree is the maximum value or degree of all the terms of the polynomial. The relative degree is the greatest exponent of a variable among all the terms of the polynomial. These concepts will help to detect linear, quadratic, and cubic equations or expressions in following classes. How to order a polynomial in ascending or descending order is also an important tool that is detailed in the classes. This topic will help to perform operations between algebraic expressions. Evaluating algebraic expressions is made by substituting given values in an algebraic expression and performing the arithmetic operations to obtain a value. This is fundamental because it will be used while constructing functions or verifying the solution of an equation. Different operations appear continuously in algebra and further mathematical classes. Hence, several operations between algebraic expressions are discussed. First, addition. We have to identify like terms, those that have literal factors with identical exponents. These elements of algebraic expressions can be added with the distributive property of multiplication. Unlike terms cannot be added. The other operation is subtraction. Subtracting algebraic expressions implies identifying minuend and subtrend. Then, obtain the additive inverse of the subtrend, so that, like terms, can be added. Before getting into multiplication and division, we have to understand the laws of exponents and radicals. Continuous practices with these formulas is crucial to perform multiplications and divisions. When performing multiplications between algebraic expressions, it must be understood that there are three cases. Monomial by monomial, which are solved by using laws of exponents. Monomial by polynomial are solved using the distributive law of multiplication and the laws of exponents per algebraic term. Finally, polynomial by polynomial, multiplying term by term, or using the same arithmetic algorithm of multiplication. There are also three cases when performing divisions between algebraic expressions. Monomial by monomial, which are solved by using laws of exponents. Monomial by polynomial are solved using the distributive law and the laws of exponents per algebraic term. Finally, polynomial by polynomial, using the same long division arithmetic algorithm with the galley. Other tools to perform operations with algebraic expressions discussed are the special products. These formulas help to perform multiplication and powers faster for specific cases and patterns. The Newton S binomial and Pascal S triangle also help for specific cases when binomials have different exponents. It is important to highlight that previous tools are going to be used while performing more complex operations. When finishing understanding how special products are performed, the inverse processes of factoring have to be studied. Starting with common factor, difference of two squares, trinomials, and sum or difference of two cubes. Each specific case needs to be fully addressed because they are crucial to simplifying rational or algebraic fractions. Different operations with rational expressions are discussed using all the previous tools. After mastering algebraic expressions, it is recommended to start analyzing the concept of equality and its properties. Hence, the concept of equation as an equality that is satisfied for some values of the variable, so that linear equations can be solved using these properties. These properties will be used to isolate variables. Other concepts addressed in the classes are relations and functions, notation, and processes to graph. A relation is any subset of the Cartesian plane. A function is a set of ordered pairs such that no two distinct pairs have the same first element. It is important to emphasize that all function is a relation, but not all relations are functions. Domain and range are also discussed to frame the boundaries of a relation. So, once we know how to solve equations and processes to graph, it is suggested to start to solve systems of two linear equations in two variables. Different procedures can be used, such as the graphing method, elimination method, equal values method, substitution method, method using determinants or Cramer's rule, and matrix method. It is essential to understand all these options because, in future classes, different types of systems of equations may appear that cannot be solved by all the methods. Then, quadratic equations and their processes to solve them is proposed to be studied. Graphing methods of quadratic equations are addressed, and solving procedures such as factoring, completing the square, and the quadratic formula. The following topic of this algebra structure is inequalities, properties, and inequations. An inequality is defined as a relationship between two expressions that are not equal. An inequation is a statement in which two expressions are not the same, and contains a set of values of the variable for which the inequality is valid. Procedures to find the solution set and its graph are studied. Once we have studied several algebraic tools, different topics, such as complex numbers, operations with radical expressions, and rationalizing the denominator can be added. In these cases, we will use laws of radicals, operations with algebraic expressions, and even special products to perform different operations. Hence, we highlight the importance of mastering the previous tools. Exponential and logarithmic functions are discussed and finalized with properties of logarithms to solve expressions. All these topics are suggested to be used as grounding tools to further algebraic topics. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com